Let's have a look at available data structures. And here it says Iterables overview, because in the end, all these data structures we'll have a look at are iterable. That basically in a nutshell means we can loop through them. They share some common functionalities when it comes to going through their values. We already learned about the list. It looks like this. We create it with squared brackets, and it can hold multiple values. In this example, it's a string. We also saw in our current blockchain implementation that it could be a nested list, so we can also store more complex data structures in a list. And what can we say about a list? It's mutable, which means we can edit it. It's ordered. The element at index 1, remember it starts at 0, so the honey in this case, will always be at that position. It won't be randomly reordered due to, for example, memory optimizations or anything like that. Duplicates are allowed. We have milk twice in here. And mostly, but that's no hard limit, we only have one type of data in a list. We only have strings, we only have booleans, though it's not a hard limit. And in our current blockchain, for example, we do have mixed types. We have lists and floats in there. This is how our list is looking right now. But in many use cases, you only work with one type of data. Now, a new data structure, a new iterable, would be a set. A set is created with the set function, which looks like that. And the interesting thing about a set is it's also mutable. We can add or remove values, but it's unordered. It's not ordered, so the order is not guaranteed. And that is very important. We can't have duplicates in there. If we add milk twice, it will only be stored once. So this is great whenever you need to manage any data where you don't want to have duplicates. Mostly, just as with lists, you manage only one type of data, but as with lists, this is no hard requirement. We also have tuples. Tuples are created with this syntax, so with normal parentheses and then with comma-separated values like a list. But the important part here is they're immutable, which means we can't edit them. We create them once, and that is how they look like. Now, this might look super unflexible at first, but it actually has advantages in some use cases. If you have some hard-coded defaults, for example, which you want to use in your application, which you never want to change in the first place, you could use a tuple for managing them. Sometimes you also want to create a tuple from user input, but you never plan on receiving further user input. And then you could use a tuple too. They are ordered just like normal lists, and they may have duplicates just like normal lists. Often, unlike normal lists, they are used with mixed types, though as you can see in this example already, that also is no hard requirement. You can have one type of data in there too. Now, some things you will sometimes see is that you use a tuple to group certain data. For example, you could have a tuple which stores items you want to buy as a first element, let's say milk, but then as a second element, unlike here in the example, it maybe stores a number to indicate how much of these items you want to buy. Now, that is a tuple. Tuples are also interesting when we have a look at a certain feature Python functions provide us. We'll also see that in this module, of course. Now, the last important data structure is a dictionary. It's created with curly braces like this, and if you're coming from the JavaScript world, this might look like a JavaScript object to you. In the end, dictionaries are basically maps. They are mutable, so you can change them. They are unordered, that's important, so the order isn't guaranteed. Name doesn't have to be the first element. And the interesting thing, of course, is what you can see, we have key-value pairs here. We have an identifier. We don't have an index starting at 0 or anything like that. We have a unique identifier, which has to be wrapped by quotation marks, by the way. So, for example, name here. And then we have a value like milk or 2. And each value is mapped to its identifier. And these identifiers, these keys, these must not be duplicate. The values, they can occur as often as you want. So we could have an additional identifier alias in that example dictionary, and it could also hold milk as a value. That would be allowed, but a second identifier name would not be allowed. Often, as in this example, you use dictionaries for mixed data types. Now, which of these types should we use for what in our blockchain?